Okay, asking, you know, what's the first thing we do when we see this function? We want to graph it, okay? Well, you can think back to what we do with polynomials. You know perfectly well for polynomials, you're going to find the zeros. Then you're going to partition the x-axis into intervals at those zeros, and you're going to figure out whether the thing's positive or negative on each interval. And you've got to have that mastered, because that's pretty easy to master, okay? And then you're going to ask yourself, what happens at the end? What happens for humongous positive x? What happens for humongous negative x? Okay? So you know whether the graph goes up on this end or down, up on this end or down. Okay? It's always going to do one or the other on each end. Okay? It's a little more complicated for rational functions. Okay? For rational function, you find the zeros of the numerator, which are the zeros of the function, provided the zero you have here isn't always a zero, isn't also a zero of the denominator, which complicates things. But if this is in lowest terms, that's not going to happen. So you get lowest terms, you find the zeros of the numerator, you find the zeros of the denominator. And that's where you partition it. Okay? So So, zero of the numerator is here, and the zeros of the numerator are the only places where the function can change sign. That can cross the x-axis. The function can change sign. It will change sign only at zeros of the numerator and zeros of the denominator. Okay? But it can only go through the x-axis at this point, if it does go through the x-axis. And -7 is the zero of the denominator. Which leads to vertical asymptote. Okay? Now, you determine the sign on each interval is going to be the same, because it can only change sign as zero of the numerator or zero of the denominator. Can't change sign between here and here because there's no zero of the numerator or denominator. Can't change sign to the right of here because same reason. Can't change sign to the left of here. These are the only zeros. Your numerators and denominators are the only places we think can change sign. So sign is the same everywhere on each of these intervals. Okay? For any interval, the sign doesn't change. And then determine end behavior. And then you construct your graph. So what I want you to take right now is this much. Okay? Now to determine the sign on each interval, we'll talk about end behavior next time.